And so now let's go through the derivation of the fundamental trig identities. We start by recalling the definition of our trigonometric functions. If we have a circle centered at the origin of radius r, we can pick a point in the xy plane, and we define the cosine of the angle theta as being x over r, sine of theta being y over r, secant of theta being r over x, cosecant of theta r over y, tangent of theta y over x, and cotangent of theta x over y. So our immediate trig identities that we can get out of that are the reciprocal identities. And we get the reciprocal identities, let's take secant of theta. Now, secant of theta is just going to be r over x by our definition, but then using some algebra, r over x is algebraically equivalent to 1 divided by x over r. But x over r is cosine of theta. And so we have our first reciprocal identity that the secant of theta is equal to 1 over the cosine of theta. We can do the same thing for the cosecant as r over y. We take the reciprocal, so that's 1 divided by y over r. Y over r becomes sine of theta, and so we have cosecant of theta is equal to 1 over sine. We can do the same thing with cotangent. Cotangent of theta is being x over y, but that's equivalent to 1 divided by y over x. Y over x is tangent of theta. Kind of using the same ideas, we have the quotient identities. Then if we look at sine of theta over cosine of theta, from our trig definitions, that's y over r divided by x over r. But if we divide by a fraction, it's the same thing as multiplying by the reciprocal, so we have y over r times r over x. The r's cancel, and we're left with y over x. Well, y over x from our trig definitions is tangent of theta. We do the same thing with cotangent. So if we start with cosine of theta over sine of theta, x over r divided by y over r, divided by a fraction, multiplied by the reciprocal, the r's cancel, we get x over y, which is cotangent of theta. So we get our quotient identities that tangent of theta is sine of theta over cosine of theta, and cotangent of theta is cosine of theta over sine of theta. For the Pythagorean identities, let's remember that the equation for a circle centered at the origin of radius r is given by x squared plus y squared is equal to r squared. So from this equation, let's divide both sides by r squared. So we get x squared over r squared, y squared over r squared, and r squared over r squared. But we can use properties of exponents, take the square to the outside, so we have x over r squared plus y over r squared, and then r squared over r squared is 1. But come back now to our trig definitions for sine and cosine. X over r is cosine, y over r gives us sine, and so we have our first Pythagorean identity given by cosine squared of theta plus sine squared of theta is 1. For the other two Pythagorean identities, we start from the identity we just derived for cosine squared plus sine squared is 1. So if we divide both sides by cosine squared, we get something that looks like cosine squared over cosine squared plus sine squared over cosine squared is equal to 1 over cosine squared. Again, playing with our properties of exponents, cosine squared over cosine squared is 1. Sine squared over cosine squared becomes sine over cosine squared, and 1 over cosine squared becomes 1 over cosine squared. Using our quotient identities and our reciprocal identities, sine over cosine becomes tangent, 1 over cosine becomes secant, and so we end up with our second Pythagorean identity of 1 plus tangent squared of theta is secant squared of theta. So for the first one, we divided by cosine squared, and so now let's divide both sides by sine squared. If we divide both sides by sine squared, we have cosine squared over sine squared plus sine squared over sine squared is equal to 1 over sine squared. Doing the same tricks with the exponents, we have a cosine over sine and a 1 over sine, which with our quotient identities and our reciprocal identities gives us cotangent of theta squared plus 1 is equal to cosecant of theta squared. Okay, and so we have our third Pythagorean identity. Cotangent squared of theta plus 1 is equal to cosecant squared of theta. So if we go through all of the fundamental identities that we have listed now, we have, starting with the reciprocal identities, the secant of theta is 1 over cosine, cosecant of theta is 1 over sine, and cotangent of theta is 1 over tangent of theta. Our quotient identities, tangent of theta is equal to sine of theta over cosine of theta, cotangent of theta is cosine of theta over sine of theta, and then our three Pythagorean identities, sine squared of theta plus cosine squared of theta is 1, 1 plus tangent squared of theta is equal to secant squared of theta, and finally 1 plus cotangent squared of theta is equal to cosecant squared of theta. So this gives us all of our fundamental identities.